In the vast, silent theater of space, a new kind of drama unfolded. On October 1st, 2024, something unprecedented happened. The China National Space Administration, or CNSA, picked up the phone, so to speak, and reached out to its American counterpart, NASA. This wasn't a casual chat. It was a serious warning about a potential cosmic fender bender. Two satellites, one Chinese and one American, were on a collision course. China, in a historic first, had detected the risk and initiated contact to coordinate a cosmic dance of avoidance. They had a simple, direct message for NASA. Hold still, we've got this. This moment was truly remarkable, a surprising twist in the story of modern space exploration. For years, the official relationship between the United States and China in space has been, to put it mildly, frosty. A piece of American legislation known as the Wolf Amendment, passed in 2011, has acted as a high wall between the two space agencies. It heavily restricts NASA from collaborating with China on a bilateral basis. This law was born from political tensions and national security concerns, effectively forcing the two biggest players in the space race to keep their distance. This history made China's proactive communication all the more significant. In this specific instance, China took the lead. They calmly informed NASA of the impending conjunction and proposed a solution. They would perform the necessary maneuver with their own satellite to steer it out of harm's way. All NASA had to do was nothing, to simply maintain its satellite's current trajectory. NASA agreed, and the Chinese satellite elegantly shifted its path, averting a disaster that could have created thousands of new pieces of dangerous space debris. The event showcased a level of maturity and capability from China's space program that caught the world's attention, demonstrating their advanced ability to monitor the orbital environment. This single act of cooperation, born out of necessity, pierced through the political barriers that have long defined the US-China space relationship. It was a practical solution to a shared problem, a moment where the immediate danger of a collision outweighed years of geopolitical rivalry. Alvin Drew, a NASA director, announced this quiet diplomatic victory at the International Astronautical Congress, highlighting it as a crucial step forward. It suggests that when faced with a clear and present danger to the shared resource of space, even the most distant of rivals can find a way to talk and work together for the common good. So, why are we suddenly so worried about satellites bumping into each other? The answer is simple. It's getting incredibly crowded up there. The region just above our atmosphere, known as low Earth orbit, or LEO, has become the cosmic equivalent of a bustling city during rush hour. As of right now, in late 2025, there are nearly 13,000 active satellites zipping around our planet. These are the workhorses of our modern world, providing everything from GPS navigation and internet service to climate monitoring and scientific data. Every single one of them is traveling at mind-boggling speeds, turning LEO into a high-stakes traffic jam. A huge part of this population boom is due to the rise of what we call mega-constellations. Think of these as vast networks of hundreds or even thousands of small, interconnected satellites working together. The most famous example is SpaceX's Starlink project, which currently accounts for a staggering 8,500 of the active satellites in LEO. That's more than 2/3 of the total. And they have plans for many, many more, with ambitions to launch tens of thousands in the coming years. This commercialization of space has revolutionized global connectivity, but it has also dramatically increased the density of objects in orbit. And it's not just American companies filling the sky. China has its own grand ambitions for space. They're actively developing their own mega-constellations like Guowang and Thousand Sails, with the goal of launching over 10,000 satellites by the 2030s. Other nations and private companies around the world are also joining the race, each eager to claim their own piece of the orbital real estate. While this competition drives innovation and expands our technological reach, it also multiplies the chances of a catastrophic encounter. Each new satellite adds another variable to an already complex equation of orbital mechanics and collision avoidance. This exponential growth presents a monumental challenge for space traffic management. We've gone from a few dozen satellites in the early days of the space age to a sky teeming with them. Imagine trying to navigate a ship through a harbor filled with thousands of other boats, all moving at different speeds and in different directions, without a central traffic control system. That's the reality we are facing in low Earth orbit today. The sheer number of objects makes coordination and communication more critical than ever before, as the October 2024 near miss between the US and China so vividly demonstrated. The problem isn't just the active satellites we're launching, it's also the junk we've left behind. For every functioning satellite, there are many more pieces of space debris, old, defunct satellites, discarded rocket stages, and fragments from past explosions or collisions. As of November 2025, we estimate there are tens of thousands of objects larger than a softball orbiting Earth. Worse, there are hundreds of thousands of smaller pieces, between 1 and 10 centimeters, that are still big enough to cause catastrophic damage. This orbital junkyard poses a constant threat to every mission and every astronaut. The danger of this debris cannot be overstated. Even a tiny fleck of paint, traveling at orbital speeds of over 17,000 miles per hour, can hit with the force of a bowling ball. A collision with a larger piece of debris can be utterly devastating. We saw a chilling reminder of this just this month, in November 2025, when 3 Chinese astronauts on the Tiangong space station had their return to Earth delayed. Their return capsule was struck by a suspected piece of space junk, forcing an emergency assessment and highlighting the real-world dangers that our spacefarers now face every single day. This brings us to a terrifying scenario that scientists call the Kessler syndrome. It was proposed by NASA scientist Donald J. Kessler in 1978. He theorized that if the density of objects in low Earth orbit becomes too high, a single collision could set off a chain reaction. The debris from one crash would then slam into other satellites, creating even more debris, which would then cause more collisions. This cascading effect could eventually render certain orbits completely unusable for generations, trapping us on Earth beneath a deadly shell of high-velocity shrapnel. The recent near miss was a warning shot. We narrowly avoided an event that could have been a trigger. Avoiding collisions is therefore not just about protecting 2 expensive satellites, it's about preserving the future of space exploration itself. Each time we successfully maneuver a satellite out of harm's way, we are preventing the creation of a new cloud of debris that would threaten every other object in orbit. The proactive communication between China and NASA wasn't just good diplomacy, it was an act of environmental stewardship for the cosmic commons. It was a crucial move to prevent our orbital highways from becoming impassable, debris-filled wastelands, ensuring that space remains a domain of discovery, not danger. The close call between the American and Chinese satellites serves as a powerful lesson. It teaches us that in the shared domain of space, isolationism is not an option. The laws of physics don't care about national borders or political disagreements. A collision over one country's airspace creates debris that will threaten satellites from every nation. The only way to manage this growing risk is through open communication, shared data, and international cooperation. We need a global space traffic management system, a kind of cosmic air traffic control, where all spacefaring nations can work together to keep the skies clear and safe for everyone. Building such a system will not be easy. It requires trust, transparency, and a willingness to put collective safety above national pride or secrecy. The Wolf Amendment, while created with national security in mind, now looks like an obstacle to the practical realities of a crowded orbital environment. The fact that an emergency situation was required to open a line of communication shows that our policies have not kept pace with our technology. We must find ways to create permanent channels for routine data sharing on satellite positions and plan maneuvers, not just when a disaster is imminent. The proliferation of satellites also poses other challenges that require a unified response. Astronomers on the ground are finding their view of the universe increasingly obstructed by streaks of light from mega-constellations, threatening our ability to make new discoveries from Earth. Radio frequencies are becoming congested, risking interference with critical communications. These are not problems that one country or one company can solve alone. They demand international agreements and standards that balance commercial interests with scientific preservation and the long-term sustainability of space activities. We must think of space as a delicate ecosystem. Ultimately, the final frontier is a resource that belongs to all of humanity. As we continue to push outwards, to explore, and to utilize space for the benefit of life on Earth, we must do so responsibly. The October 2024 incident was a wake-up call. It showed us both the danger of our crowded skies and the potential for cooperation to overcome it. Let it be the catalyst for a new era of space diplomacy, one where all nations work as partners to chart a safe and sustainable course through the cosmos. Our future in space depends not on who wins the race, but on how we all learn to navigate it together.